To truly understand reinforcement learning, we need to grasp a few core concepts that define the framework within which agents learn. These are Markov Decision Processes, or MDPs, policies, and value functions. Most RL problems are formalized as Markov Decision Processes. An MDP provides a mathematical framework for modeling sequential decision-making in situations where outcomes are partly random and partly under the control of a decision-maker. It consists of states, S, the current situation or configuration of the environment; actions, A, the choices the agent can make in a given state; transition probability, P, the probability of moving from one state to another after taking an action; and reward function, R, the immediate reward received after taking an action in a state. A key property of an MDP is the Markov property. The future state depends only on the current state and the action taken, not on the entire history of past states and actions. This simplifies the modeling process significantly. Next, the policy. The policy is the agent's strategy or behavior. It defines how the agent chooses an action given a particular state. A policy can be deterministic, always choose one action, or stochastic, choose actions with probabilities. The goal of RL is to find the optimal policy that maximizes the cumulative reward. Finally, value functions. These are critical for guiding the agent's learning. A value function estimates how good it is for an agent to be in a particular state or to take an action in a state under a given policy. The state value function, V of S, tells us the expected total future reward starting from state S and following a given policy. The action value function, Q of S, A, also known as the Q value, tells us the expected total future reward starting from state S, taking action A, and then following a given policy. The agent uses these value functions to evaluate its decisions. By learning which states or state-action pairs lead to higher cumulative rewards, the agent can refine its policy to make better choices over time. These three concepts, MDPs for formalizing the problem, policies for defining behavior, and value functions for evaluating behavior, form the backbone of almost all reinforcement learning algorithms. Next, we'll look at a fundamental RL algorithm, Q-learning.